Hello, morning everyone. Morning. So after the good sleep, what do you feel? Now, anyone who have tried out the calculations of delta H, okay, on this chapter? I know that some of you would love to watch the videos just after the lesson. But we have got quite a number of you here, right? So I would like you guys to let me know your status first of all. How many of you who plan to follow the this topic, which means you still haven't learned anything. Could you please let me know? Okay, could you please put the hands up for those who really don't know anything about delta H? No. Those who are one. You haven't watched the video? Not yet? How about Lê Kiệt Hong? Not yet. Oh, so this lesson you may find it quite maybe quite challenging because we have covered some of the essential skills of the of doing the calculations. So I would now first of all I would like to talk to you about today's lecture. Right, we continue on drawing this enthalpy cycle. Okay, we continue to draw this enthalpy cycle. Do you know what that is? Okay, so and we are going to take a further look on those two enthalpy terms, right? We have we do hope that we need to master the skills of writing those enthalpy cycle, and when time is allowed, we will continue on doing something like the algebraic method. So yesterday I asked you guys to give me the voting, right? So I would like to know your. I found that algebraic method, two of you don't know. Well, for enthalpy cycle, three of you don't know. How about the others? You don't know neither. Neither, right? You don't know anything about this. So that's why in this lesson we would focus on this part. We get to know some of the two methods in detail, and we have got two more works to go. First of all, I'll try to have as easy as that because for that two topic, 35.3 and 35.4 is something very easy because you may see some standard enthalpy terms and use it as a shorthand method to calculate. Now, recall your memory about the questions last night. Do you realize why Mr. Chin will ask you to do this one? Do you know which question is question 19? It's question 19. Is it? Yeah, question 19. The reaction about cracking on page 72. On page 72. Can you see that? Now, so you may see the whole the enthalpy cycle, you can just write it down as a triangle like this, right? It seems like a triangle. While if you take a look on those terms very carefully, okay, and try to see that saying very carefully, what can you conclude about that reaction, right? No matter it is cracking, right? We just say that cracking, but all those enthalpy terms is just combustion. Can you see that? So the delta H of reaction is calculated as the delta H of combustion of this. This is a reactant, while minus we have got that too. You get the summation of the two of the product. So for this one, you can generalize it. Now, first of all, it is reactant. While the final two, they are the product. You're going to minus sign here. Can you see that? So we use the delta of combustion term. So what is that? So what is that? If you refer to the book page 57, we have got a equation, right? You have got a formula to generalize those things, okay? Which is the delta H of the reaction of a compound. It's not. It's just the combustion of those terms. So you may see that too. So this one, you can also generalize it as delta H of the reaction. It is the sum of a formation, sum of the delta H of the combustions, okay, of the reactants, minus sum of the delta H of the combustion of product. Now, these two is a little bit different, right? But you can do such a very similar generalization of this. Okay, so you may use this formula to get to know the reaction about the delta H. Now, for this part, what is that about? You'll be given some delta H of combustion terms of both the elements and compounds. Okay, so the question is, I want to get to know this one. It is unknown, so it is root. It's one of the roots. So what you're going to do is to find out the delta H of combustion data indirectly to get to know these reactions. Okay, so you get the point. So this is what it is very similar to what you know it in question 19 in your chapter exercise. Very similar. Now, one thing I would like to mention with you is that this one, you will see the plus oxygen here, right? So you better put that inside the boxes, okay, such that those boxes, the content inside, okay, are conserved. Now, this is what I would like to remind you once again. Now, you may see so many different examples on the market, or maybe the exercise from the publishers outside, and they would love to put those oxygen on top of the next to the arrow. So this may be rather confusing to some of you, especially while you are going to show me the cycle, having each box the same number of particles inside. Can you get a point? So you remember, put that oxygen inside the boxes for calculations. So similarly, what I want to refer to is this, right? So you instead of writing a box like this, you are going to put a box together with this. Together with this. Can you get a point? You find difficult? Do you get what I mean? So it is what you are going to have these boxes together. Okay. So we have similarly, we have got two methods. You have got the enthalpy cycle method, and also you may use this equation to tell. Okay, you may use this equation, and together with your third method, it is algebraic formula, algebraic method, right? It is also possible to get the same idea. How would you get that? Do you know how to solve this one? Now you are going to use it as algebraic method. Of course you can. How? We've got that three terms. So what I'm going to do is to find out the delta H of formation of this equation, which is 2 carbon or graphite, 2C graphite plus hydrogen gas to form C2H2 gas. It is the delta H of formation in which you would like to find. Can you get a point? So take a look on these enthalpy data. What you're going to do is to collect those similar terms, and I put it on the left-hand side, right? For example, this one graphite. Now I try to use different color and such that you will know what I mean, right? Graphite, graphite. Can you see? So you may put this as written like this, but because you may find it as what? 2 carbon, right? 2 carbon. So you need to put a 2 here. 2 and 2. What happens to that data? It will become 2. Do you understand? So by doing so, you may get this together. And what's next? What's next? You are going to have hydrogen. Hydrogen. So hydrogen, I would like to use another pen, right? Hydrogen. So we have got hydrogen 1 mole here. They are both on the left-hand side. So don't worry, just add this in this direction. With that, this is times 1. Can you get a point? So what is so special is about the final equation on top of it. On top of it. So what is that? You are going to write it in reverse. So this is 2 CO2, H2O, liquid to form E fine, C2H2 gas, plus 5/2 O2. Can you get this? Okay. And then this one, what will happen? But that equation is not delta H of combustion, is minus delta H of combustion, right? So it is now becoming what? Plus 1,300 kilojoule per mole. Can you get a point? Now, what's next? You're going to write it down as this direction. Can you get a point? So what's next is on to try to cancel out some like terms. What is the like terms? What are the like terms? Something that I did not highlight with you, right? Yes, that's right. So first of all, CO2, yes, that's one. This one can be cancelled out. Can you see that? CO2 can be cancelled out. What else? Oh, how about H2O? H2O can also be cancelled out. Can you see that? H2O can be cancelled out. And similarly, yes, that's right. So you may find the oxygen. Oxygen can be cancelled out. Okay. And afterward, what do you find is you try to add a sum of that 3. Okay, and you can get the same equation as written. Okay, so you may find that, how about these 2? These 2, it is just the reactant, right? The delta H, sum of the delta H of combustion of the reactant. Can you see that? And how about this? I write it in reverse. So it is just the sum of the formation of the combustion of the product. By doing so, you can get the answer. The formula is here. Do you understand? Do you understand the whole thing? So because of that, you may have 1 more equations, right, for you to continue. Any questions?李健朗, you just give me the clock. What do you mean by that? You are going to leave? So this is what I would like to solve with you. Now, how about this? Your turn. Question 1 and 2. So what a terrible questions asking you 1A, right? So you are going to be assigned to be asked to draw the enthalpy cycle.李振傑, so late. So do you know how to solve? Take a look on question 1. Question 1. Can you write down the enthalpy cycle? Of course, once you know the formula, that equation can be solved so quickly. you may solve the equation very, very quickly, right? But what I want to ask you guys to do is to draw the enthalpy cycle. I would like to ask you guys to right here, right? Is it right here? How? How? So I would like to give you the whiteboard instead, right? Whiteboard. Anyone who can have a try on it. The enthalpy terms. Anyone who can try on it? Yeah. That is method 1. Enthalpy cycle method. Two graphite, 2 hydrogen gas, and half mole of O2 to form what is FNL, right? FNL. And we have got somebody you write oxygen here, right? So originally it is 1/2, right? 1/2 is a half, right? But how come you write that O2 here? This one? Oh, you want to do combustion, right? So don't worry. If you are going to ask to do the combustion, I will let you guys write down those items right here. How? Now, originally it is 1/2, right? Originally that equation I would like to find out is 2 carbon. I just continue work. Don't cross it out. No need. I would like you guys to get to know what is that. So it is 2 carbon graphite plus 2 hydrogen gas plus half mole of O2 gas to form FNL. So this is the delta H of reaction to be obtained. This is what I would like to find, right? What is that delta H? This is what I would like to get. So what this guy is now doing is we have got that boxes, right? Originally that boxes, that's good. That boxes, what else? So you are going to find out some similar terms. 5/2, 5/2, and finally 2 carbon, 2 hydrogen. Yes, that's right. So let us check the data, right, one by one. While he's writing, just continue, right? This one, this enthalpy change is now going to find, right? This with the delta H formation. This is what I would like to get, right? This is the one. This is the one, right? Can you see that? And what he's now going to do is to find out the 2 combustion term. One is combustion of graphite, while the other one is combustion of hydrogen, with the corresponding ratio. Now take a look. Yes, that's right. You need to give a ratio times something. You omit something. So you may find this one is FNL. I use this one as example. FNL, combustion of FNL, it requires to have this to form 2 CO2 and 2 H2O. What is that? Combustion, right? So we have got here, right? The same. It is on your equation 1. equation 1, it is minus 1167 kilojoule per mole. Can you see it? Can you see it? So what's next is on those other items. So you are going to have two graphite. Indeed, they would use what? They would use 2 oxygen to react, right? So here comes 2 times, can you see that? 2 times graphite, C chemical combustion of graphite to form what? To form 2 carbon dioxide, this one. This is the one. So we have got 2 times 2 here. Can you see that? Times 2. And what's next is to have this one. We have got the hydrogen. We've got hydrogen. 2 hydrogen, they would get half mole of O2 to form what? To form 2 moles of water. So that's why this solution, we'll just write down 5/2 O2 here, right? It is in line. The green one and the blue one is the same as the orange one. Can you see that? Can you see that? The same part, right? It's 5/2 the same. So that's why here, what is now going to do is to write down times 2. Times 2 here. Times 2. Just times 2. Can you get? Can you get what I mean, right? Times 2 of delta H of combustion of hydrogen gas, such that you may get such that you may get this. And finally, the cycle has now finished. So according to Hess's law, so what will you get about this? Is it just what? Delta H of formation of ethanol is just equal to what? Oh, we've got root 1 here, right? I will show the root, right? This is the root 1, root 2. Okay, so you're going to relate the root 2 together. So what is root 2? Root 2, it is 2 times delta H of combustion of graphite, C graphite, plus 2 times delta H of combustion of hydrogen, minus, right, because it is now going in reverse, right, minus delta H of combustion of CH3, CHO liquid. Can you see that part? So what you're going to do is to put that data into it. So you may get it 2 times C graphite. What is that? It is minus 394. Here is that, plus 2 times minus 286 for what delta H of combustion of hydrogen gas, minus what? Minus negative 1167. So what you will get, it is minus 193 kilojoule per mole. Okay, so this is the answer. Do you know how to solve? Do you know how to solve? Do you have some other method to solve this? Now, first of all, for those who want to continue with this part, could you please capture the screen first, capture the screen, and then we are going to do the same questions or using different method. Okay, because many of you have got confusion, right? Don't worry, you will stick back to this practice to get to know the free method. Is that clear? Okay. Hi. Second method. All of you have copied it down? Now, yes. Just cross out. Okay, second method. Second method, method 2. Algebraic method. Algebraic method. So your task is to solve the delta H of formation of what? Of ethanol. So the equation for this, right? So you write down something like this. So C graphite times what? How many? We've got 2, right? 2 times, okay, plus hydrogen plus oxygen to form methanol. So you're going to find out the mole ratio is 2 here. Remember, this one must be stick back to 1, right? So you are going to force to make this one is 2. You got the point? And this one, it is 1/2. So this is the final task, the final equation that you're going to draw. You need to draw something like this. Okay? So what you're going to do is to write down those like terms on the left-hand side and put it on the right-hand side in order to solve. Can you get a point? So what are those 3 terms? So what are the 3 terms? So could you please write down those 3 terms here? What are they? Anyone who can try? This is the final equation I would like to have. Ethanol. This is the one. Okay. So how to put that there? First of all, just recall your memory. What is that? You're going to find out like terms. Combustion, right? Of graphite. So what you write down for combustion of graphite, what is that? So what is that? Remember times 2, right? So it is, first of all, write down 1 mole first. Graphite time plus O2 to form CO2. Because we have got times 2, such that you can make it balance, right? 2, 2, 2 times 2. Do you understand? Do you understand? So what's next? So what's next? You're going to write the second term. It is hydrogen, delta combustion of hydrogen, because it is listed as 2 mole of hydrogen, right? To be burned. So you write down hydrogen times 2. So what is meant by times 2? So first of all, just give me 1, which is this. Okay, so because of times 2, here comes this, right? And what is that? What is now becoming? It's just 1 mole. How about this one? It's 2 mole. Exactly. And finally, on this, what is that? Delta H of combustion of this term. So you are going to imagine something like this, okay? Imagine you are going to put down something like this, plus O2, you burn it, right, to form CO2 and H2O. Now, so I would like to write down something like this. Just imagine you are going to write down from the reverse side, from right-hand side to left-hand side. So what will you get for the CO2 and H2O? How will you balance it? We've got 2 carbon here, right? So you have got 2. What else? He what's next to balance is this hydrogen, right? 3 plus 1 is 4, is 2. So 2 times 2 is equal to 4. 4 plus 2 is 6. 6 minus 1 is 5. So the power of this one is 5 over 2. Can you get a point? 5 over 2, here comes this. And originally, I write down like this, okay? But this time, the arrow is not that sign, it's reverse sign. Reverse sign. So the answer for this one is minus delta H of combustion of CH3CHO liquid. Can you get a point? So what is that delta H actually? I would like to find out this one, right? How? So you are going to make a summation of this. You add it together. So which means delta H of combustion of formation of methanol, it is equal to what? Delta H of combustion of graphite times 2 plus delta H of combustion of hydrogen gas times 2 minus delta H of combustion of methanol. So you will get the same answer as method 1. Okay, so what is that? I would like to tell you the method 3 as well here. The method 3 is a formula, right? But what is the formula? Delta H of formation of a substance. This is just sum of delta H of combustion of reactants minus delta H, sum of the delta H of combustion of the product. This is the formula. So if you don't want to, you find it so difficult, right? So what you're going to do is to memorize this formula, and that's it. Okay, clear? The 3 methods has been shown on using the same item. Questions? Questions? How many of you think that it is okay to have that 3 methods? Now, could you please put a tick here? Put a tick in a chat box. Tell me. You understand? You really understand that 3 method? Could you please put a tick? Just one tick. Two. Just 2. How about the others? Going to have a breakfast, or you just open the device and go back to sleep? 盧少華, where are you? 盧少華, where are you? Hello, 盧少華. Hi, 李健朗. 趙家明, you are here, right? 陳俊熙. 溫之維, yeah. 李彤 have left, right? You put a cross. Which one? Which one do you think you need to put a cross? You don't understand method 1. You understand method 3? What is that? Method 3 is the same as method 2. It just uses a formula. What is that? This one we call it sum of this one. This one. What's that? It is sum, 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 which means I add all those reactants together. Okay, so this is what I listed here, right? The same. How about this? The sum of the delta H of combustion product is this one. So it's just a subtraction of those two items. And believe it or not, you are going to take a look on question 2. Now, question 2, you use the same concept. If you know method 1, if you know method 2, how about method 3? You use method 3 and you can solve it so easily. The question is selenium. It is formed from the reaction of silicon and hydrogen. The combustion of selenium gives silicon dioxide and water. So standard enthalpy changes of combustion of silicon and hydrogen. They are minus 911, minus 286, respectively. Calculate the standard enthalpy change of formation of selenium. Can you get the whole picture, right? Have you all kept the picture, right? So you just delete them. Okay? Have you all kept that? Have you all kept that? Yeah, I would like to cross them out now. And I do question 2. Question 2. So the question is asking for you have going to find out the delta H of formation of selenium. You're going to find out this, the task. It is to find out delta H of formation of selenium. SiH4 gas, which is what? Which is exactly what is that? It is silicon, hydrogen, 2 hydrogen to form SiH4. So this is the task, right? So you are going to find out this one. So this is what you are going to find. You get it. And what's next is to find out the if you write down method 3, it's very simple. It's very simple. It is just write down the delta H of formation of selenium, which is equal to the sum of the delta H of combustion of the reactants minus the sum of the delta H of combustion of product. So it is just what? It is just the we have got what is meant by sum of a conventional combustion reactant. Reactant is on this side, right? So which is delta H of combustion of silicon plus 2 times delta H of combustion of hydrogen. Can you get the point? And what's next? It's product. Product is here. So minus, remember to put minus delta H of combustion of SiH4. Okay, So the question seems easier, right? So which is equal to what? Equal to this one, it is minus 911 plus 2 times minus 286 for hydrogen, combustion hydrogen, minus this one, SiH4. You are right on the combustion given in the equation is minus 170, 1517. So this is the answer. The answer is plus 34 kilojoule per mole. Okay. Plus. You forgot to write down the word plus, right? Plus sign. Plus 34 kilojoule per mole. This is method 3. It's easy, right? You may do the same action on method 1 and method 2 to solve. Okay. Question? How about method 1 and method 2? Do you know how to solve it? Can you use method 1 and method 2 to solve for the same questions? Especially for those who just put a cross here, right? You know what to do, right? So you write down method 1 and method 2. So anyone who can try it, method 1 and method 2, you do the same thing. How we solve this? Anyone who can try that? Anyone who can try? Oh, all gone away. Now, how about I put that 2, right? Here, right? Method 1 and method 2. I draw a line here, right? Such that all of you would know what to do. This one, I use enthalpy cycle method. Okay. Well, for the others, you could algebraic method. Can you solve that? How about cycle? No one wants to have a try on it. How about algebraic method? No one's want to try. Can I have one more person to do algebraic method? Yeah. Wow. Now I need to put it in history, right? 吳偉豪
Hi.
920.
Sorry.
We need to have the first lesson. It's 8:35. Where have you been?
So sleepy.
So sleepy? Or you're just talking with your girlfriends for so late last night? Do you know where we are going to do the calculations using different methods, and we are having 3 methods: enthalpy cycle method, algebraic method, and also using the formula. Do you know how to solve? Or talk with girlfriends? Oh, I see. Bravo. 陳偉豪 Hey, wait, how about the others? 3 minutes has been passed, but it seems nothing, right? So you may see this one, enthalpy cycle method. You may write down this. How about arrow? You don't have any arrow, right? How about arrow? Hello. How about the arrow? Wow, one more, it is even late. 蟻卓爺 morning, so late. You should be the one to do. You should the one to be to do the algebraic method. 蟻卓爺 蟻卓爺 You just drop out. Now take a look on those left hand side. I would like to assist this guy. Try to see the enthalpy terms here. What is that? What are those enthalpy terms? The one on the this one is just delta H of combustion, right? Delta H of combustion of SiH4 gas. Can you see that? So how about this? Now this is the one that you write on the on the book, right? On the book is given. What is this? How about the others? How about this? How about this one? Delta H of what? It is from the elements, right? Elements, right? To form SiH4. But you may see that these two terms, they are the same, right? So these is from these to this, right? Can you see that? From these to this. Yes, formation. Formation of what? SiH4 gas. Can you get a point? Can you get it? So indeed, of course, it's not crossed it out. Oh, sorry. Oh, sorry. I cross out so many things. Sorry. So it is Si solid plus 2H2 gas, okay, plus something to form SiH4 gas. How about O2? How many O2 are here? How many O2? We have got O2, 2O, right? So we have got how many? You're going to balance the whole thing, right? 2O2. Agree? 2O2. 2O2. So you may get it as what? 2O2. The same, right? How about this? Finally, SiO2. So you will use that O2, one O2. And the other one, H2O, you have going to use another O2, right? Can you see that? So here comes 2O2. Can you get a point? So what is that? So it is delta H of combustion of Si solid plus 2 times delta H of combustion of hydrogen. Can you get it? So the remaining is just, now you're going to check the boxes, the content of the boxes here. The content of the boxes here, the content of the boxes here. Are they the same? Are they the same? Okay, the same content. So what is mean by the same? We have got Si, you need to count Si. You are going to add H account O to see if they are there. One Si for 3 hydrogen. We've got 4 hydrogen. How about O2? O, actually, it is 4, right? All those, they are balanced. Can you check? Okay. So you may get this. So finally, what is the delta H? The calculations part. Here comes the calculation part. What is that? Delta H of formation. This is our task. Delta H of formation of SiH4 gas. What is that? Delta H of formation. This is root 1. You are going to find it, right? So what is root 2? You're going to have this direction. Can you get it? So the root 2, it is from this and this. First of all, right, you may find it as what? Delta H of combustion of silicon plus 2 times delta H of combustion of hydrogen. And finally, it is minus, right? Because it's a reverse reaction. So this is the delta H of combustion of selenium. So you are going to do the same action. So for the silicon, it is minus 911 plus 2 times minus 286 minus negative 1517. And what you will get, it is plus 34 kilojoule per mole. The same. The same. Okay. How about the one on the right hand side? You still haven't finished. How about algebraic method? Hi, come on. So maybe I cross them out, right? I would like to write down. Gave up drawing. I don't want to say that I would like to give you up. You just jump to the answer directly. You should not be this, okay? Finish. Now take a look on the sky. I remember to what? Remember to show. Remember to show what? Remember to show the stick symbols. Okay, so this is what I would like to remind those guys. Stick symbols. So you are going to write down stick symbols. So you are going to write them down like this. SI or H4 is G. This one, sorry. And now the enthalpy terms. What are the enthalpy terms? SiO2, Si is silicon, is minus 911 on your left hand side. So what's next? How about this? How about this? It is 2 times minus 286, right? How about this? How about this? It's just the opposite of the given equation, right? It is what's that? This is minus 1517. So what you're going to do is to get a summation of this plus this plus this. So you may get this equation. So delta H of conformation of SiH4, which is equal to what? Minus 911 plus 2 times minus 86 and minus 1517, which is also equal to 34 kilojoule per mole. Okay, is that clear? Can you get the whole thing? Can you get the whole thing? So I would like to show you your level of understanding of this. Let me see. This one. Can you see? Can you see the statistics result? Can you see that? No. Oh, you just see the screen. You just see the screen. Let me see. I need to cap the screen with you. The screen. Let me see. I no longer have the capture the screen function. How come? Oh, it doesn't matter. So I would like to guys. I don't know where. I don't know where because. Oh, so strange. It doesn't matter. I will cap the screen and let you know. And the first one is on your level of understanding of your general equation. Here comes 3 to 4, 4 guys, 5 to 6, 4 guys, 7 to 8, 4. Question 2, mainly your distribution lies on from 5 to 8. From 5 to 8. And finally, for question 3, or from 1 to 8, it's from 1 to 8. Still in extreme. Still extreme. So this is what I will find it rather challenging. Okay. Or just 15 of you give a vote. How about the others? No. Okay, I just stop it here because we have got 3 methods. Your votes have told me whether or not you understand, right? So there will be more questions to come and go home and try to search it. And tonight we focus on the class practice as well as the ending of the final chapter because we have got so many exercises to go. The principles, they are not difficult, right? But it's a matter of time to practice. The more you practice, the more you know what to do. Questions? Now, if not, I will see you guys tonight. Bye-bye. Choi Junming is not here, right? Oh.